The great fireball that is the sun, burning away in the sky. Except the sun isn't made out of fire, and so by extension isn't burning, so how does the sun actually work? The Sun is a huge ball of ionized gas, which is a state of matter called plasma. It is roughly 700,000 kilometers across, which is pretty big. About 90% of it is made up of hydrogen, the lightest, simplest and most abundant element in the universe. This hydrogen is the fuel of the Sun and all stars, and is the reason why we are all alive today. The Sun can be thought of as a huge stellar power station, releasing more energy in the form of radiation, light, and high-energy particles than the entire population of the world uses in a year. So how does it produce all of this raw power? Well, the answer is nuclear bombs, but backwards. Whereas a nuclear bomb releases an unthinkable amount of energy in one huge explosion by splitting large atoms apart in a process called nuclear fission, the Sun releases vast amounts of energy continuously by squeezing atoms together via a process called nuclear fusion. Fusion is the ultimate physical process whereby atomic nuclei are fused together to form larger nuclei, and in the case of the Sun, the explosive gas hydrogen is fused into the inert gas helium, the one that makes your voice all squeaky and allows balloons to seemingly defy gravity. Fusion is only possible because in the Sun's core there are very specific conditions. First of all, the Sun's state of matter, plasma. Plasma is just a fancy type of gas where all the electrons of the atoms become free from the nucleus and basically exist as a rich soup of particles all colliding into one another. This state of matter is not as exotic as you may think. Neon lights, St. Elmo's fire, and aptly named plasma balls all contain this ionized gas state. Actually, plasma is the most abundant state of matter in the universe, just because all stars are made up of it. There are two other important conditions that stellar fusion requires: extreme heat and pressure. The pressures are so crushingly large, reaching to around 250 billion atmospheres, which is quite frankly incomprehensible. And the heat is equally as hellish, reaching to an insane 15 million Kelvin, and under these conditions, hydrogen nuclei in the stellar core start colliding into each other, following a complex chain reaction. First, two hydrogen nuclei, which are actually just protons, are forced together and fuse. Protons hate being together. Being the same electric charge as each other, they want nothing more than to be as far away from each other as possible. But the heat and pressure won't allow them to split up, so a novel solution is created. One of the protons actually decays into a neutron. This matchup is much more stable, so the nucleus stays together as a deuterium nucleus, which is an isotope of hydrogen. By decaying into a neutron, the transmuting proton emits a neutrino, a tiny, virtually massless particle that is related to the electron. In fact, these neutrons are so numerous and so tiny that trillions of them pass through you every second, and only one or two of them will ever interact with your atoms in your entire life. Then, another proton crashes the party and collides into the freshly made deuterium nucleus. This results in the entire nucleus becoming that of helium-3. Now, this is the main energy-producing stage of the reaction. This reaction right here is what causes the helium-3 nucleus to release a gamma-ray photon, the source of all the Sun's energy. After the formation of the helium-3 nuclei, two of them come together and fuse, releasing two protons and settle as a helium-4 nucleus, your basic helium atom. The two protons emitted will then go back into the stellar core and start the fusion reaction all over again. Now here's where physics goes a bit weird. The helium nuclei created is actually lighter than the combined masses of two protons and two neutrons. How can something be less than the sum of its parts? Simple. Some of the mass of the protons and neutrons is converted into the neutrinos and gamma rays. Okay, now we know the fusion mechanism. How does that actually translate into the Sun being the reason for our being? Well, the gamma rays emitted from stellar fusion are highly energetic and they're a reason for practically all life on Earth. However, in this highly energetic form, gamma rays are deadly, capable of destroying DNA, killing organs, and causing cancer. So what turns these gamma rays into a usable format like light and heat? Well, it's our good friend plasma that steps in to save the day. As we said earlier, plasma contains many free electrons. These free electrons are very good at absorbing and emitting electromagnetic radiation. In fact, a gamma ray can barely move more than a nanometer without being intercepted by an electron. As the rays collide into the nuclei and get absorbed and emitted by electrons, they lose energy in the form of heat to their surroundings, keeping the core hot and ready for more fusion. This heat and radiation given off by the gamma rays actually keeps the sun in a nice, stable equilibrium, the heat pushing outwards with the same force as gravity pulls inwards on the core. Without this balancing of forces, the sun would collapse into a neutron star or even a black hole. In fact, the core of the sun is so hot, packed and dense that it actually takes around 1,000,000 years for just one photon to escape from the core to the surface of the sun. For comparison, the 150 million kilometer trip from the surface of the sun to Earth takes a little over 8 minutes for a photon. Of course, there still are gamma rays, X-rays and ultraviolet light being emitted from the sun, but at least in manageable quantities, so that we don't all die every time we walk outside. So, by converting a little bit of nuclear mass into pure energy, the sun blazes brighter than anything in our sky. Its incredibly powerful and efficient way of releasing energy has kept the sun going for over 5 billion years, and is set to keep going for another 5 billion more. The sun. The reason why we're alive, the reason for practically all life on Earth, and of course, the reason for this video. Also, if you enjoyed the video, please like, share and subscribe to really help get this channel off its feet. Thank you.